This jar of honey is worth $200, and every drop was made by 60,000 bees working 18 hours a day. In the remote hills of New Zealand, a single flowering bush produces the most expensive honey on Earth, Manuka honey, liquid gold at $200 per jar. Every frame you are about to see was built cell by cell, filled drop by drop, and capped by bees that flew over 55,000 kilometers to produce it. From a beehive in the New Zealand bush to a pharmacy shelf in Tokyo, this is how $200 honey is really made. Inside this facility in the Bay of Plenty, 80 workers process over 300 tons of raw Manuka honey every season. New Zealand and parts of southeastern Australia are the only places on Earth where Leptospermum sciparium, the Manuka bush, grows in sufficient density for commercial honey production. During peak season, up to 40 deliveries arrive daily from apiaries across the region, each carrying raw honeycomb that must be extracted within hours. This facility processes honey from over 12,000 beehives spread across 200 remote locations, some accessible only by helicopter. Manuka honey was considered low-grade bush honey for decades. It wasn't until the 1980s that researchers at the University of Waikato discovered its extraordinary antibacterial properties. The journey begins here, in the remote native bush where Manuka flowers for just 2 to 6 weeks each summer. Each flower produces nectar for only a few days. The bees must work every available bloom before the narrow window closes. Manuka nectar contains methylglyoxal, a compound found in no other honey source on Earth. It is this molecule that makes Manuka worth 50 times more than regular honey. Flower density varies dramatically between sites. Beekeepers scout locations months in advance, mapping the bush to predict which hillsides will produce the highest MgO concentrations. Weeks before the bloom, beekeepers transport thousands of hives into remote Manuka-rich bush, positioning them for maximum nectar access. The most remote sites require helicopter placement. A single load carries 8 to 10 hives worth over $50,000 in future honey production. Some apiaries sit in locations so remote that the beekeeper visits only twice, once to place the hives and once to collect the harvest. Hive placement is strategic. Each colony needs access to flowering Manuka within a 3-kilometer flight radius. Beyond that, the bees waste energy in transit. A single helicopter day costs over $5,000. The premium Manuka harvest from a remote site must justify that investment, a calculation that depends entirely on the unpredictable bloom. Some of the highest MgO honey comes from the most inaccessible sites, where pure Manuka stands have never been cleared or mixed with competing floral sources. A single forager bee visits up to 1,500 flowers per trip, collecting a payload of nectar that weighs almost as much as the bee itself. In her entire 6-week summer lifespan, a single forager bee produces just 1/12 of a teaspoon of honey. That jar of Manuka represents the lifetime work of thousands. Loaded foragers return to the hive and transfer their nectar cargo to receiver bees through mouth-to-mouth exchange, a process called trophallaxis. Inside the hive, receiver bees chew the raw nectar for up to 30 minutes, adding invertase enzymes that break complex sugars into simple glucose and fructose. The honey stomach is a separate organ from the bee's digestive system. It holds up to 40 milligrams of nectar, nearly the bee's own body weight, during the return flight. Raw nectar is roughly 80% water. The bees must reduce that to below 18% before the honey is shelf-stable, a process that takes several days per cell. Processed nectar is deposited into hexagonal wax cells, each cell holding roughly 1/3 of a gram of liquid that will thicken into finished honey. A full honey super contains 10 frames, roughly 20 kilograms of finished honey. A productive colony can fill 2 supers during a strong Manuka bloom. Thousands of bees fan their wings in coordinated shifts throughout the night, generating airflow that evaporates water from the open cells. When moisture drops below 18%, workers seal each cell with a wax cap, nature's quality approval stamp that the honey is shelf-stable. A fully capped frame contains roughly 2 kilograms of finished honey. The combined output of thousands of bees working for several weeks. Bees produce wax from specialized abdominal glands. Building a single kilogram of comb requires roughly 8 kilograms of consumed honey, making wax production enormously expensive in energy terms. 4 to 6 weeks after placement, the beekeeper returns. The Manuka bloom is ending and the harvest window has arrived. Smoke triggers the bees' natural fire response. They gorge on honey in preparation to flee, becoming docile and less likely to sting. Each frame is inspected for cap coverage. Only frames that are at least 90% capped are harvested. The rest need more time. Bees are brushed from each frame rather than shaken. A gentler method that minimizes colony stress during the harvest disruption. A single remote site yields 10 to 30 harvest boxes, each containing 8 frames of raw Manuka honeycomb destined for the processing facility. Every box is tagged with its exact GPS coordinates. This location data becomes critical later when testing confirms Manuka authenticity. A responsible beekeeper never takes everything. At least 10 kilograms of honey must remain in each hive, the colony's survival insurance for the coming months. Intact comb is valuable. Returning drawn frame saves each colony the energy of producing fresh wax, the equivalent of 40 kilograms of consumed honey per each hive. Every harvest is documented by site. Yield data from each location feeds into next season's placement decisions, confirming which valleys consistently produce the highest grade honey. The raw honeycomb must reach the facility within 48 hours of harvest to prevent fermentation from moisture reabsorption in humid conditions. Inside the facility, every box is logged and queued for extraction in the order it arrived. First in, first processed. The first processing step removes the wax caps that the bees so carefully applied, exposing the raw honey beneath. Heated blades slice through the wax in a single pass. The cappings, still rich with residual honey, are collected separately for beeswax production. Uncapped frames enter the centrifugal extractor, a spinning drum that uses centrifugal force to pull honey from the comb without destroying the wax structure. At full speed, the extractor pulls over 95% of the honey from each frame in under 3 minutes. The golden liquid cascading down the drum walls. Gravity transfer avoids the shearing forces of pumps, preserving the honey's natural crystal structure and delicate enzyme activity. Coarse filtration removes wax particles and debris. Manuka honey is never fine filtered or heat treated. Both processes destroy the delicate methyl glyoxyl compounds that determine its value. Raw honey settles in temperature-controlled tanks for 24 to 48 hours. Air bubbles and remaining fine particles rise to the surface naturally. Moisture content must be below 20% for commercial stability. Premium Manuka typically arrives at 17 to 18%, the bees having done most of the work already. The foam layer is skimmed by hand rather than by filtration, preserving the pollen grains and natural compounds that certified Manuka must contain. Ultra-filtered honey may look prettier, but it has been stripped of the very compounds that make Manuka valuable. The slight cloudiness is actually a quality indicator. Before any honey leaves the settling tanks, laboratory testing determines whether it qualifies as genuine Manuka and at what grade. The testing laboratory is the facility's most critical department. Without certified test results, the honey is worth a fraction of its potential value. HPLC analysis measures methyl glyoxyl concentration to the milligram. This single number determines whether a batch is worth $20 or $200 per jar. The price curve is exponential. MGO 850 plus honey commands over 10 times the price of MGO 100, yet comes from the same species of flower. This batch registers MGO 876, qualifying as ultra-premium grade worth over $200 per F500-gram jar. Pollen analysis provides botanical confirmation. Genuine Manuka honey must contain a minimum percentage of Leptospermum scoparium pollen grains. New Zealand's Ministry for Primary Industries conducts unannounced facility audits, verifying that every batch claim matches laboratory evidence. Penalties for non-compliance include criminal prosecution. Each pollen grain is a fingerprint linking the honey to its floral source. The New Zealand government requires DNA verification for every export batch. DNA testing confirms species-level identification of the nectar source, the definitive test that separates genuine Manuka from counterfeits flooding the global market. Leptospirin is Manuka's unforgeable signature. Unlike MGO, which can theoretically be added artificially, leptospirin exists only in genuine Manuka nectar, making it the ultimate authenticity marker. New Zealand's government-mandated 5-attribute test is the world's most rigorous honey authentication standard, required for every batch before export clearance. The scale of Manuka fraud is staggering. New Zealand produces roughly 1,700 tons annually. Yet, over 10,000 tons of products labeled Manuka are sold worldwide. The UMF Unique Manuka Factor grading system was created specifically to combat fraud, providing consumers with an independently verified quality guarantee. Every certified jar carries a UMF rating linked to its specific batch test results, scannable by consumers worldwide to verify authenticity. Only after testing confirms grade, purity, and authenticity does the honey receive release authorization for bottling. Direct-to-consumer sales now represent over 20% of revenue. Premium customers ordering high MGO jars directly from the producer for guaranteed authenticity. The bottling line fills 1,200 jars per are with precisely measured honey, every jar containing exactly 500 grams within a 1-gram tolerance. The filling temperature is maintained at exactly 35 degrees, warm enough for smooth flow, but cool enough to preserve every bioactive compound. Every cap is torqued to a precise specification, tight enough for tamper evidence, but engineered to open without excessive force for the consumer. Labels are printed with batch-specific data in real time, linking each jar to its HPLC test certificate, harvest location, and extraction date. From empty jar to sealed, labeled product takes less than 60 seconds per unit, but the honey inside took bees over 2 months to produce. Final line inspection rejects roughly 2% of production, primarily for label misalignment or fill level inconsistency. Each case of 12 premium jars represents over $2,400 in retail value, packed and sealed within the hour. The warehouse holds up to 4 months of finished inventory, over $1 million of certified Manuka honey waiting for global distribution. Tamper-evident seals protect against adulteration in the supply chain, a critical concern in a market plagued by counterfeiting and dilution fraud. Japan is Manuka's largest export market, consuming over 30% of New Zealand's premium production. Temperature-controlled shipping maintains 18 degrees from factory to destination. Heat above 30 degrees degrades methylglyoxal over extended periods. New Zealand exports Manuka honey to over 45 countries, a single agricultural product generating over $350 million in annual export revenue. Nothing is wasted. Beeswax cappings removed during extraction are melted, filtered, and sold as a valuable secondary product. Regular mite monitoring determines treatment timing. Above 3 mites per 100 bees triggers immediate intervention to prevent colony collapse. Varroa reproduces inside capped brood cells, feeding on developing pupae. Infested bees emerge weakened, with deformed wings and compromised immune systems. A kilogram of pure beeswax sells for $30 to $40, used in cosmetics, candle making, pharmaceutical coatings, and food wrapping. Propolis, the antimicrobial resin bees used to seal their hive, is collected from frame edges and processed into tinctures and capsules worth over $100 per kilogram. Beyond honey and wax, the facility processes propolis, bee pollen, and royal jelly, each commanding premium prices in the health supplement market. Extracted frames are returned to the hives. Drawn comb gives the bees a head start on next season, saving weeks of energy-intensive wax production. Manuka honey's antibacterial properties are clinically proven. Medical-grade Manuka is used in wound dressings approved by health authorities in over 30 countries. Hospital wound care units apply sterilized Manuka honey directly to burns, surgical wounds, and diabetic ulcers. Its natural antibacterial action promoting healing. Spring colony splitting doubles hive numbers without purchasing new bees. Each split receives a mated queen, either raised on site or purchased from specialist queen breeders. In Japanese pharmacies and health food stores, premium Manuka honey occupies dedicated display sections, marketed as both a food and a health supplement. From premium food to medical device to luxury skincare ingredient, Manuka honey spans industries no other honey can reach. After harvest, the beekeeper's priority shifts to colony survival. Enough honey must remain in each hive to sustain 60,000 bees through winter. Product development extends Manuka into new categories: sports nutrition, functional beverages, and premium skincare formulations that leverage its bioactive properties. Luxury skincare brands incorporate Manuka honey as a hero ingredient. Its antimicrobial and moisturizing properties marketed in products costing over $200 per jar. A healthy brood pattern indicates a strong queen and a colony, likely to survive winter and produce abundantly the following season. Colony losses average 15 to 20% through a New Zealand winter. Varroa mites, disease, and starvation are the primary threats. Varroa destructor, a parasitic mite from Asia, arrived in New Zealand in 2000 and has been the single greatest threat to the beekeeping industry ever since. The Varroa mite attaches to adult bees and developing larvae, feeding on fat reserves and transmitting viruses that can collapse an entire colony within months. Supplemental sugar syrup feeding bridges the gap between the last autumn nectar flow and the first spring blooms, preventing starvation during the coldest months. Through winter, the colony contracts to a tight cluster inside the hive, vibrating their flight muscles to generate heat that maintains a core temperature of 35 degrees. Winter preparation includes insulating hives and reducing entrances. The colony must maintain 35 degrees at its core, while outside temperatures drop near freezing. When spring returns and the first Manuka buds appear, the cycle begins again. The queen increases her laying rate to build the workforce needed for harvest. At peak production, the queen lays up to 2,000 eggs per Dalton Y, building the colony from a winter cluster of 10,000 to a summer army of 60,000. The entire annual cycle revolves around that narrow 2 to 6 week Manuka flowering window. One bad storm during bloom can destroy an entire season's production. When conditions align, warm days, calm winds, no heavy rain, the Manuka hillsides explode in white bloom and the bees work from dawn to dusk. Back inside the facility, this season's harvest is running at full capacity. Over 1,200 jars per H are moved through the bottling line. The lab runs 24 hours during peak season, every tank of honey awaiting its test results before receiving bottling clearance. Viscosity changes with temperature by the degree. Too cold and the honey won't flow evenly. Too warm and it fills too fast, trapping air bubbles in the jar. Random pull inspections verify that every jar meets the labeled weight. Underfilling by even 5 grams is a regulatory violation in export markets. Each batch certificate becomes a legal document, its accuracy backed by government inspection and subject to criminal penalties for falsification. At peak throughput, this single facility processes over 5 tons of certified Manuka honey per week into finished consumer products. A single pallet of premium MGO 850 plus Manuka honey carries a retail value exceeding $50,000. The price difference is extraordinary. Premium Manuka costs 20 times more than quality clover honey, justified by its unique biochemistry and the narrow harvest window. From flower to sealed jar, the journey takes roughly 3 months. But the ecosystem that makes it possible has been evolving for millions of years. 60,000 bees, 1,500 flower visits per trip. 1/12 of a teaspoon per lifetime. $200 per jar. That is how 60,000 bees and a single flowering bush create liquid gold worth $200 a jar. The most valuable honey on Earth. Each season's success depends on factors beyond human control: rainfall timing, temperature patterns, wind during bloom. The beekeeper works with nature, never against it. New Zealand's Manuka beekeepers are guardians of a unique ecosystem. Their livelihood depends on protecting the native bush that commercial development increasingly threatens. If this journey fascinated you, subscribe and hit the bell. Next time we're heading inside a factory where 10 million lobsters are raised from hatchlings to fine dining.